If you're a junior engineer, whole dwelling ventilation is one of those Part F topics that sounds simple until you actually try to apply it. Because this is where a lot of people stop thinking in systems and start hunting for one number. And that is usually where the confusion starts. By the end of this video, you'll understand what whole dwelling ventilation actually means, where the two key calculation routes come from, and why Part F is really asking you to think about the dwelling as a complete ventilation system, not just a collection of rooms. Whole dwelling ventilation is the background fresh air side of the strategy. It is there to dilute, disperse and remove moisture and pollutants that are not fully removed by local extract. In other words, your kitchen and bathroom extract deal with pollutants at source, but whole dwelling ventilation supports the overall air quality across the home. This is one of the easiest places for junior engineers to get tripped up, because people often remember the extract side first. They remember bathroom fans. They remember kitchen rates. But the dwelling still needs a minimum background level of fresh air supply. Approved Document F says the minimum whole dwelling ventilation rate should meet both of the following conditions. First, a minimum rate of 0.3 litres per second per square metre of internal floor area. Second, a minimum rate determined by the number of bedrooms, using Table 1.3. And the key thing is this, you check both, and the higher value governs. That is the bit people often miss. They calculate one route, stop there, and assume they are done. But Part F is asking you to compare two methods. Floor area method, bedroom number method. So let's simplify that. If you have a dwelling, you first look at the internal floor area. That means all internal floor area across all floors. If it is a two-story dwelling, you add both floors together. Then you multiply by 0.3 litres per second per square metre. That gives you one candidate whole dwelling ventilation rate. Then you check the bedroom-based rate from Table 1.3. The table gives 1 bedroom equals 19 litres per second. 2 bedrooms equals 25 litres per second. 3 bedrooms equals 31 litres per second. 4 bedrooms equals 37 litres per second. 5 bedrooms equals 43 litres per second. And for each additional bedroom above that, you add 6 litres per second. So now you have two numbers. And this is the main junior engineer takeaway. You do not choose the easier one. You use the larger one. That larger value becomes your minimum whole dwelling ventilation rate. Now what actually provides that air? Approved Document F says supply air for the dwelling should be delivered either through continuous supply fans or background ventilators. So this is where your wider system strategy matters. If the dwelling is naturally ventilated, background ventilators, like trickle vents, are part of how that air is provided. If the dwelling has a mechanical supply route, that changes how the air is delivered, but the whole dwelling requirement still exists. This is why whole dwelling ventilation should not be thought of as just a number in isolation. It links directly to the ventilation strategy you've chosen. And it also links to internal air transfer. Paragraph 1.21 says internal doors should allow air to flow through the dwelling by providing a minimum free area equivalent to a 10 mm undercut in a 760 mm wide door. So even if you get the supply side right, you still need the air path to work through the home. That is a really important design mindset. Because a lot of drawings can look compliant in isolation. A vent may be shown, a fan may be shown, but if the air cannot actually move through the dwelling properly, then the strategy is weaker than it looks. Now let's talk about the common mistakes. The first mistake is calculating only one method and stopping. The second is forgetting that internal floor area includes all floors. The third is treating whole dwelling ventilation as though it replaces extract. It doesn't. It works alongside extract ventilation and purge ventilation as part of the wider three-part strategy. The fourth is forgetting that the whole dwelling rate needs to tie back to the system type. If you have continuous extract, the total combined continuous extract rate should be at least the whole dwelling rate. If you are relying on background ventilators, then those ventilators need to be selected and arranged to support the strategy properly. So if you want the simple version, here it is. Whole dwelling ventilation is the minimum background fresh air provision for the home. You calculate it in two ways, by floor area, by number of bedrooms, and the larger result wins. That number then has to make sense with the ventilation strategy, the air supply route, and the internal transfer path. If you're a junior engineer, this is one of the most useful Part F concepts to understand early, because once this clicks, the rest of the residential ventilation strategy starts making much more sense. This video is based on Approved Document F Volume 1, 2026 edition, so always check the full guidance for project-specific compliance. If this helped, subscribe to The Lazy Engineer, because I'm breaking Part F down section by section in a way that is actually useful for junior engineers.